Hey guys, welcome back. This week we are going to learn about angles, okay? And this upcoming week we'll practice angles. So go ahead and take, again, my lesson today is going to be actually on PowerPoint. So again, you can always, since this, I have things laid out already, it might be, I don't want to rush you when you guys take notes. So maybe you want to stop and rewind. I want to make an emphasis on that, especially in this video, since you can't see me and I have things laid out on a PowerPoint already. So things are written already. So you might, again, I don't want to rush you when you take your notes. So feel free to pause and rewind as much as you can, okay? Again, so reminders, this is due on Google Classroom as well. Just as far as the time goes, make sure you get it in by Sunday night before midnight, okay? So let's give this a shot. Let's learn how to name angles first, okay? Um, First of all, there are four ways to name an angle, okay? And those four ways, probably the most common way that you'll see me or the book name angles is this first method, okay? Um, and how you're going to name angles through this method is your vertex, right? Which is this guy right here. Your vertex um, should be the middle letter, okay? And then the points, and then you're going to use the points from each side. So again, I could say, hey, this would be angle CBA, right? So I could say angle CBA. Again, I'm referring to angle B. Or I could say angle ABC, right? And I'm still referring to this angle right here, okay? Now, there are other ways to name this angle, okay? Uh, you could also use the vertex only. So I could just say angle B, but again, probably not the best way to do it because you could have other angles that are a part of this vertex as well. So you don't want to just say angle B when there's other angles part of the same vertex, okay? You could also say angle 1 as well. Again, these are all appropriate names, at least for this example, to name or to label a angle. Okay, so this is all you want to do is either use three letters, B being the vertex, or using your middle letter as your vertex. You could say angle B or angle 1. Okay, classifying angles. Okay, these angles, some of you guys might be familiar with already. Acute angles are anything less than 90. Okay, right angles are exactly 90, and obtuse angles are between, well, greater than 90 but less than 180. So examples of those are these guys right here. So these angles. So again, this is an acute angle. That's less than 90 degrees. I've got my right angle, and what you notice about my right angle is to specify that this is a right angle and it is 90 degrees. There's a little box that you see there that specifies that this angle, so if you ever see that box, it's telling you it is 90 degrees, okay? And then I've got my obtuse angle right here, greater than 90, but less than 180. So this is the biggest angle, well, possibly the biggest angle. Obviously, there's bigger angles, but out of these three, this is the biggest angle that you can get. Greater than 90, but less than 180. You also have the straight angle, okay? And that's exactly what it means. It's simply a straight angle, again, from start to finish, it is 180 degrees, okay? Now, of course, as you know, a full circle is 360 degrees, so this is half, essentially half the angle of a circle, okay? All right, some vocab, okay? Um, Again, just a reminder, pause, rewind. I'll go through each of these examples one by one. Let's start with adjacent angles. Again, adjacent meaning any angles that are right next to each other. So those are two angles that share a vertex, okay? They share that vertex, but don't overlap. So a quick example would be this guy right here, okay? So I've got angle A and angle B. These would be adjacent angles. So they share that vertex right there, um, but they don't overlap. So these would be adjacent angles. Vertical angles, on the other hand, though that would be, again, two angles that share a vertex, okay, but are opposite of each other. Okay, an example of that, it would be what I have here. Again, they share that vertex right where my mouse is, and they're directly opposite of each other. These angles are equal, okay? So these diagonal, when they're diagonally across from each other, they are equal to each other. So if angle A is, I don't know, 50 degrees, angle B is also 50 degrees, okay? Complementary angles, okay? Those are two angles whose measures will add up to 90 degrees. Each angle is called the complement of each other, okay? An example of that, again, there's many different examples I can come up with. This is just one quick example. In this case, I have POQ, angle POQ being equal to 67 degrees, and I have angle CBA being equal to 23 degrees. 23 and 67 will add up to 90 degrees, so these angles would be complements of each other, okay, or complementary. Supplementary angles, okay? Those are two angles whose measure add up to 180, okay? We just saw what a 180-degree angle looks like. Each angle, again, is the supplement of each other, okay? Quick example of that would be right here, right? 60 and 120, these two angles right here would be supplementary angles, okay? Their sum would add up to 180, okay? An angle bisector is a ray or a line that divides in two equal parts. Again, bisector is a word that we used this week, last week as well. So two equal parts, those ray or segments start at the vertex itself. So let's go ahead and take a look at what that is. Again, I've got my example here. What I'm specifying here is basically that this angle, right, and the adjacent angle, this angle, are the same, okay? They're the same because we have a bisector, that segment running through the middle, right? This bisector is cutting this angle right in half, okay? Again, forgive me for my mouse here. It's hard to write on the screen, but let's call this angle A, and let's call this angle B. Angle A and angle B, sorry. Angle A and angle B are equal to each other, okay? So that bisector cuts that angle in half. A linear pair. A linear pair is two adjacent angles. Again, we know what that means now. Two adjacent angles that form 180 degrees, so they're supplementary. So angles that form a linear pair are supplementary, okay? A quick example of that, again, this would be a linear pair. This actually would also be a linear pair. As you can see, they look very similar. Again, A and B, they add up to 180. They're adjacent. They share the same vertex. So again, that's things to kind of know from here on out. Okay, so let's do some examples. Let's actually practice what we just learned. Okay, so we're going to go ahead and answer these 5 questions. We're going to go ahead and take a look at this diagram. So let's talk about angle 1 and angle 2. We're going to use the vocab that we just learned. So look at angle 1 and angle 2. Well, first and foremost, right, they are supplementary, right? They are on a straight angle. Their angle 1 and angle 2 will add up to 180 degrees, so they are supplementary. But there's more to it, right? What else are they? They are also a linear pair, right? Angle 1 and angle 2, they're adjacent angles that also add up to 180. So that's, again, that criteria fits what linear pair is all about. And they're also adjacent angles, okay? They're right next to each other. Let's talk about 3 and 4, okay? Notice that box symbolizing a right angle. So if I know that, I know 3 and 4, would be complementary, right? 3 and 4 add up to 90 degrees. I also know that they're adjacent angles as well because they're right next to each other. They share that vertex right there. Okay, 4 and 5. 4 and 5, again, there's not much to it. All we kind of have is just adjacent angles. Okay, 1 and 3, take a look at 1 and 3. We have our first vertical angles. Okay, 1 and 3 are directly opposite each other. Okay, they're diagonally across from each other and they share that vertex. Okay, so those would be vertical angles. So 1 and 3 are equal to each other. And 5 and 6. Okay, so if I know that this is 90 degrees, right? I also know that this is also 90 degrees. So this guy is also 90 degrees. Okay, well, if I know that this is 90 degrees, again, 90 plus 90, it does make a straight angle. Okay, so this angle that you see here, this straight angle that you see here, makes an angle of 180 degrees. So I know 5 and 6 are adjacent, right? They're right next to each other, but they're also complementary, okay? Because 5 and 6 add up to 90 degrees. Again, we know that because this is 90, but which makes this also 90 because we have got one straight angle here, okay? Okay, example 3. Here's what we have. We've got the following. Okay, we have this diagram to kind of go off of, but we also know that AF is an angle bisector of angle GAE. So go ahead and take a look at GAE. That would be right here. So GAE, okay? That means F is that angle bisector, okay? So this is cutting up GAE in half, okay? So let's see what we have here. It asks us angle EAF first. Okay, so we got angle EAF. Well, what could that possibly be again? I've got a right angle here. That's 42. Well, if this is 42, this would have to be 48, right? Because 48 plus 42 is equal to 90 degrees, and we know that this is a 90-degree angle. So we know that this is 48. Okay, you can forgive me for my handwriting here. GAF, okay? So for GAF, what do we have here? So G, A, and F. Okay, well, we're talking about this angle right here. Okay, well, how do we figure that out? Remember that this is our bisector. AF is our bisector. So if this is 48, well, this would also have to be 48 because again, this angle right here is being cut in half. Okay, so GAF would also have to be 48 as well. Okay, let's go ahead and put that in. Okay, BAC. BAC, again, let's go ahead and point that out. Let's see where that is. That's BAC. That's BAC. Well, what do you notice about that? Well, they share a vertex. This angle and this angle are directly opposite each other. Well, that would be vertical angles. So I know BAC would have to be 48 as well. Okay, these numbers just work out that way. This is not going to happen all the time. But BAC would also be 48. Okay, well, what about CAD? CAD, again, let's point that out. C, A, and D. Okay, well, how do we figure that out? Go ahead and take a look at what we have. Again, use what you have to your advantage. So for example, I've got the following here. So I've got a straight angle here, right? It's a complete straight angle. We know that's 180 degrees. If I know that this is 48 and this is 48, oops, and that's 48, That's 42. Well, I could find what that missing angle is, because what I could do is 180, right? 180 minus 48, 48, and 42. I would end up getting that missing angle as 42 degrees, okay? And next, HAB. HAB in this case, let's go ahead and point that out. HAB, okay. Well, again, HAB would actually turn out to be, there's different ways you can kind of go about this. We do know that this is 90. We know that this is a straight angle, so this would have to be 90 degrees, okay? We also know that this and this are vertical angles, so that's another way you can go about it. Okay, I'm actually going to have you guys do this one for your practice problem. Okay, so I don't want to run the video too long. So for example 3, you want to go ahead and say, again, this is your example. Go ahead and put those values in and evaluate for angle FAE, okay, the measure of angle FAE. Okay, so go ahead and try this out. This would be your practice problem. So go ahead and do this, attempt it, and submit it onto Google Classroom. Okay. All right, now I'll see you guys next week.